So go ahead and turn to page 2 of your blue guided practice packet. And we're going to take a look at number 5 together, starting with the stuff that we learned yesterday. What's the degree of this polynomial? And maybe a good thing to start with is to say, is this in factored form or standard form? This is in factored form. So we want to add the multiplicities in order to find the degree. So we've got a multiplicity of 3, a multiplicity of 2. Now, if you're looking at that -3 going, does that count towards its multiplicity? The answer would be no. When we think about the degree in standard form, it's all about the highest variable power. So that little -3 out in front, that's not going to affect the multiplicity numbers or the degree at all. So this is in factored form. Those are my multiplicities. So what's my degree for this one? It's a degree 5 polynomial. So that means it is odd degree. So its end behavior is going to be doing that disco dance. Is our leading coefficient positive or negative for this one? It's a negative. So since it's odd, it's doing the disco dance. Since the leading coefficient is negative, the right arrow will be going down and the left arrow will be going up. So we know that the ends of my graph are going to look like that. Let's move to our x-intercepts next. If x minus 1 is a factor, then x equals 1 is an x-intercept. And since that multiplicity is 2, are we going to bounce or are we going to cross? We're going to bounce. So 1, 2 step, we go down, we hit the axis, it comes back up. So I always think degree 2, 1, 2 step for bounce. Now, our next x-intercept is going to be at -1. Bloop. Opposite sign as the factor. Now, this has a multiplicity of 3. Technically, it would be wiggle, but I would much rather say that it is cross. So I'm not going to hold you responsible for that. You can just say that it crosses through. The third and final point that we can find on this one is the y-intercept. And we're going to keep writing that skeletal structure of the y-intercept just to hit it home that your y-intercept is 0 and a number, whereas your x-intercept is a number and 0. So folks, let's go ahead and plug 0 in for the x values in that equation. So y equals -3 times 0 minus 1 squared, 0 plus 1 cubed. And let's make sure we're following PEMDAS. We've got -3. 0 minus 1 is -1 squared. 0 plus 1 is 1 cubed. And now we got to be careful. So exponents, if I have -1 squared, that's -1 times -1, which is a positive 1. Now, I'm pretty sure we've shown this before, but just in case, if you're going to use your calculator on this, those parentheses are very, very, very important because it shows that I'm taking -1 times -1, whereas this says the opposite of 1 squared. So folks, if you're like, ooh, I'm a little nervous about that parentheses rule, these are usually going to be very friendly numbers to square. I would always just do it in your head instead of even messing around with the calculator. So -1 times -1 will be a positive 1. And then 1 times 1 times 1 is 1. And -3 times 1 times 1 is -3. So that means my y-intercept is 0, -3. All right, folks. So now let's try to sketch the graph. It's going to cross through this point and is going to be going up on the left side. So I'm just going to curve up like this. Then it needs to come down and hit that y-intercept. And then, boink, it bounces off the x-axis and heads down. Are we all good with turning points here? How many turning points does this graph have? 1, 2. This function that's degree 5 could have 4 at most. Is it okay that it has less than 4? Absolutely. All good. So this is a sketch of what our graph would look like. And just for fun, let's see what this sucker looks like on our calculator. -3, x minus 1 squared, x plus 1 cubed. And as you can see, it is more of a cubic looking wiggle through this point instead of the cross where it curves into it and it curves out of it. Bless you. But the rest of it is pretty spot on. So again, our calculator is awesome, but we're able to get a pretty reliable sketch just from using these key features. So if you're like, I'm just going to use my calculator and just roughly sketch all of them. Nope, I'm going to be looking for this work telling me you know what the stuff is for the function, what the exact x-intercepts are, can you plot them, do you know how it's behaving there, and also the y-intercept. So folks, as far as work goes on these, I'm going to want to see this stuff. It's not a bad idea to check the turning points. How'd you find the y-intercepts? How'd you find the x-intercepts? And the behavior at those points. So yes, you can use your calculator to check yourself, but there is a considerable amount of work to be shown here. We have now done 3 examples. What questions do you guys have so far? Yes?
Is this all that's going to be on the test on Friday? Or?
Pretty much the only other thing we're going to be doing today is starting with the graph and then trying to write the equation for that graph. But yep, that's it. So this is a very short unit. So it's pretty much graph key features, how to describe them, going forward to the graph, going backward from the graph to the equation. And yep, that's it. So super short. So if you're like, what are we going to be doing tomorrow then? We're really just going to keep practicing all of this stuff. So I'm hoping we can just finish the notes today and not have anything new tomorrow. So we'll kind of have 2 days of review for this just because it is short, but there is a lot here. We'll also be doing a homework quiz that covers all the stuff we've learned so far tomorrow. So you can see, all right, if the test was tomorrow, how am I doing with this stuff just from basic memory? More questions? Let's try, Let's try number 8. See if you can determine the degree, the leading coefficient, and what those end behavior arrows should look like. So those steps that we did up here. You can state the turning points if you want, the most turning points it could have. But you certainly don't have to. So degree, odd or even, sign of the leading coefficient. And we're looking at number 8. Show me with your arms. What's your end behavior doing? This or this or this or this. You can show me with your fingers too. You don't want to lift up your arms. It should be going up and up. So our degree for this one, we add the multiplicities and 2 plus 2 gives me 4. 4 is an even number, so even degree. And our leading coefficient, there's no number explicitly written out in front of those factors, so we can assume there's a 1 there. Not just a 1, a positive 1. So positive leading coefficient, even degree, and behavior goes in the same direction, up and up. Next, see if you can find the x-intercepts for this one and determine, will they bounce, will they cross? Bless you. If it's x plus 2 as a factor, it's x equals negative 2 as the root. If it's x minus 3 as a factor, it's x equals 3 as the root. So opposite sign, so plunk, there's one root at negative 2. Plunk, there's the other one at positive 3. Folks, how is it behaving at both of those roots if the multiplicity is 2? It's gonna bounce. Bounce, bounce. Even multiplicity bounces off the axis. The last thing to find is the y-intercept. I'm going to give you a full minute to see if you can find this by plugging in 0 for the x's. Folks, what are we getting for our y-intercept, and why does it make us a little bit uneasy?
13.
Bigger. 36. So, ooh, and I'm glad you said that, 13. So, folks, when we have this in factored form, there's multiplication here, there's multiplication here. So once I simplified those exponents, there's multiplication in between those as well. So implied multiplication once you simplify those exponents. Now, the problem with 0.36 is, you know, our graph doesn't go all the way up there. And I don't know about you, but I'm not too keen on counting all the way up to 36, even though I could probably get a good estimate using that axis above. So it's like, what are we going to do with that y-intercept? We're just going to say that way up here is our y-intercept. We're still going to state that it's at 0.36, but it is out of our viewing window, similar to how it would be out of our viewing window on our calculator. So how we are going to draw this is the left end behavior starts going up to infinity. We bounce, boink, so we got to come back up. We got to come back up. And somewhere off the scope of our graph, we hit that y-axis. And we start coming back down on the other side of our y-axis to bounce again and come back up. So we still want to find the y-intercept, and we still have to draw it as if somewhere way up here, it's going to hit that value of 0.36. And I will show you what that looks like on your calculator as well. So x plus 2 squared, x minus 3 squared, And as you can see on my calculator, does it look like we have a y-intercept that's way off the scope of our window? Yep. Now, if I adjust my window, let's put my y max at 40. Don't worry about what I'm doing here. I can see if I zoom out that it's hitting that y-axis at that point. It starts to curve up a little bit more after that y-intercept, and then it comes back down. So it's not an exact sketch, but we do know that it will hit the y-axis and that it will come back down and be this happy little W shape. And that's our graph. Folks, what questions do we have on this? Do we like Unit 3 so far? It's better than linear programming, right? All right, folks, so here's what we're going to do. I think we'll save these two problems as a warm-up for tomorrow. So we are going to go back into the notes,